chamber. Now retort just means to reburn.
Over here, please.
Just some 1/2-inch holes drilled in the bottom of this. This is a 30-gallon drum. We're going to fill that with feedstock. There's nothing on the bottom drilled out on this one. Okay, the outside drum is sealed on the bottom, so the inside drum is sitting against that bottom. And we're going to fill the inside drum with feedstock. Now we just happen to have really high-class feedstock. This is coming out of furniture factories, so it's nice and dry hardwood. It's like the Cadillac of feedstock. So you can think of it as an oven. Now we put the top on there. If you want to see, it's just the inside barrel's full now. The outside barrel's not. Closed top on the inside barrel. Now we're going to fit more wood in here in the in-between spaces between these two barrels. Again, we're doing this with some pretty high-class feedstock here. Southern yellow pine in this case. And we're filling in the annular space between the two. The drier the wood is that you're using, the better off. Burn down on the outside of the inside can. In between the cans, it's going to burn down through. We've got primary air holes down here. So our air is going to get sucked up in here and keep this fire going. It's interesting that we're starting it on top and not on the bottom. The fire is going to slowly burn down because the air is coming from down here up through the fire. As it does, it's going to cook the inside container, heating the wood that's in that container, which is sealed except for those holes on the bottom. Now the gases that we cook out of that wood are all flammable gases. Anytime you see smoke, like this smoke right here, you're throwing fuel away. That smoke is fuel. And if you can get it to burn, you're going to turn that fuel into energy. So this is a simple way of doing that. When that inside can, if you can imagine it, starts to cook, makes the gas has got nowhere to go because the top is sealed. It forces its way out the bottom, comes out in between the cans, ends up getting sucked up between the cans until it hits the coals. Now these are secondary air holes, we call them. And what that will do is if there's any residual gas still coming through here and we haven't gotten enough oxygen in from down low, it will pull air in here and burn it before it gets out the chimney. You can hear the fire now. As soon as you put a chimney on it, now you've got the thermal siphon going, and it's pulling our primary air in here and our secondary air in here. We've got lots of fire going on right here. It's going to get hot real fast right here. And we'll end up, even with a 4-foot stack, you'll end up seeing flame coming out of the top of this. But notice what you're not seeing coming out the top of this is smoke. We're going to work real hard to get the balance. I think of it like a carburetor in an old-style engine, getting the balance between the fuel gas and the air mixture and the right amount of heat, and you got a clean burn all day long. That's the energy we're going to try and catch. Right now there's a big stream of hot air coming out of this, which hopefully is mostly CO2 and water vapor, because that's what we're trying to get to, is a clean burn where there's no particulates and certainly no carbon monoxide. In the first phase, we're getting that inside can hot. Thank you, John. And then in the second phase, it makes the gas, which bubbles out the bottom, comes up into the fire and ignites. This would be the second phase, and we get lots of fire from the gas. Once the gas is gone and it runs out of gas, that's when the hard carbon is left behind. So the fire then starts to go down and it finishes burning the stuff on the outside. By the time that gets down, it's really cooked that inner chamber of all of its gas.